Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I welcome you to the next session of the Linux lecture series. Today we are going to talk about the partitioning of a hard disk. If you have not taken the previous lecture that was about the hard disk geometry, I advise you to please go through that session so that you should be able to understand these lectures properly. So, what is disk partition? What is disk partition? Right, students, when we build a house, we partition it into different areas like one or more bedrooms depending on the requirements, a living and a drawing room, then maybe a main area with an attached dirty kitchen. Depending on the area of the house, you may have a front lawn as well as you can keep a kitchen garden at the back. And finally, you can have a car porch for one or maybe more cars. The same thing happens with the hard disk as well. To use it properly, we need to partition it. Partitioning your disk means dividing your disk into logical parts. Dividing your disk into logical parts. In the Microsoft world, you can see the partitions with the names like C colon, D colon, and so on. While in the Linux world, or the Unisys world, you see the partitions with something like /div /sda1 /div /sda2 and so on. Over here, the first two characters, the SD, they represent the type of the disk interface. If you have a SD over here, which in most of the cases you will find, that means you have a SCSI or a SATA disk And previously you may find in some old systems HD over here, and HD was for the ATA interface. The third character, which is A over here, represent the number of the disk. For example, if you have only one disk, you will find an A over here. If you have two or more disks, you may find a B or a C or something else over here. This third character, rather a digit, which is 2 over here, represent the partition of this disk. And soon, gentlemen, we will see that we can have 4 primary partitions. Sorry, let me take it to somewhere here. Okay, we have 4 primary partitions which can be named by 1, 2, 3 or 4. You can have one extended partition and its number can be 1, 2, 4 again. And then you can have logical partitions within the extended partition whose number starts from 5 onward. We will talk about the numbering and the partition types later as well. So before we jump into partitioning our hard disk, let's talk about some advantages of having partition. First advantage is the better organization of data. Better organization of data. So you can organize your data better if you have different partitions. The second is multiple file systems. We will talk about file systems in the next session, inshallah. If you want to have different file systems on different partitions, like FAT16, FAT32, NTFS, extended FAT, VFAT, ext2, ext3, ext4, RazorFS, UFS, you need to have different partitions. So this is one of the biggest advantage of having partitions, that you can have multiple file systems on each partition. Then another advantage is no crossing of partition limits. By this I mean that files cannot grow across partitions. So there may be some files which grow overnight, like the log files. So you keep them on a separate partition so that they should not spill over the entire disk. You may like to implement quotas. In order to limit the amount of space that users or groups can take on the file system. And then you may like to have a read-only partition. We can mount a file system on a partition that seldom change as read-only. And if you mount a file system as read-only, this reduces the recovery time of a file system after a system crash. So after seeing the advantages of the file systems, let's see that what are the recommended partitions on Linux. The two main types of partitions on Linux. You can have swap partitions. You can have, normally we have one, but you can have more as well. It is basically the expansion of the computer's physical memory on hard disk. It is hidden from the user and only accessible to the system itself. And it is kept normally twice the size of the available physical memory. After having one swap partition, we can have one or more data partitions. There may be many data partitions, but at least there must be one, and that one is called the root partition, represented by a /. This is the root partition. This is called the root partition. So whenever you install Linux on your machine, at least there will be two partitions. One, the root partition, and the other, the swap partition. This root partition basically contains all the data to start up and run the system. Students, in Linux, you have seen the file system hierarchy. There are certain directories which are the candidates to be mounted on separate partitions. The directories which are the candidates to be mounted on separate partitions are the boot partition, which contains the kernel image, the home partition for users' personal data, similarly var and USR, and maybe more. You can mount these directories in separate partitions. And after system startup, these and all other partitions that you make appear under the root partition as an inverted tree, which you have seen. So everything appears under root. Whether they are separate partitions or not, they will appear like this. But if they are, you will be given more options to handle them, to mount them, to put different file systems on them. Right, gentlemen, partitions are normally created while you are doing installation of the operating system. But later as well, you can create the partitions, you can delete them, and you can resize them. And today we will see how we can do all these tasks after the installation of the operating system. Before we start doing this, let's have an overview of the idea of partition table. Suppose we have made 4 partitions on our hard disk. Let's suppose that this is a linear view of our hard disk, which is having 4 partitions, P1, P2, P3, partition 3, and P4, partition 4. P1 starts from here, P1 finishes here, P2 starts from here, P2 finishes here, and so on. The question is, how does the operating system knows where does a partition starts and where it ends, and the next starts? The answer is partition table. So a partition table is maintained on disk, and it is a structure which efficiently manages information about different partitions on a hard disk. Let me write it down for you. A partition table is maintained on disk, on your hard disk, and it is a structure which manages and efficiently manages information about different partitions of a hard disk drive. And there are different types of partition table. The one which is most common and everybody knows about it is the master boot record partitioning table. The other one which is getting very common these days is the globally unique identifier partitioning table, which is called GPT. It is the latest standard of laying out the partitioning of hard disks used by Windows and Linux these days. Then we have APM, the Apple partitioning map. We have the BSD disk label. We have Sun, SGI, and there are others as well. Well, gentlemen, there are a lot of tools that are used to perform partitioning. Tools. Let's talk about tools on the same slide. The tool which we are going to use today is Fdisk. It is a dialog-driven program for creation and manipulation of the partition table, and it is capable of creating the MBR partitions, and the latest versions are also capable of handling the GPT as well as the BSD and Sun and SGI partitioning table as well. Then we have gdisk. It is also a text mode and menu driven program, and it is normally used for GPT partitions. Then we have part editor, partition editor, part D. We have gpart editor. This is GNOME partition editor, GUI based. These two are normally used for GPT BST as partition table. Then we have the cfdisk, which is curses based program for partitioning the block devices. And this cfdisk no longer supports CHS addressing, which we have read in the last session. We have sfdisk. It is script oriented tool for partitioning block devices, and there may be more as well. So gentlemen, let's see that what kind of partition our system shows to us right now. I am root because doing all these things you need root privileges. There is a program part X which gives you information about the existing partitions on your disk. You can read the man page at your time, but right now I just want to show you the different partitions which I have on my machine currently. So this shows there are about 8 partitions, 1, 2, 3, 4, 5, 6, 7, 8. The starting and the ending sector number. These are the total number of sectors in a partition. This is the size shown in human readable form. The first partition is of 9.3 GB. The next partition is of about 2 GB and so on. And we don't have the labels assigned to our partitions, and this is the UUID of a partition. So we have a lot of partitions over here. Fine. Right, gentlemen, let's move ahead and try to dig out a little bit more detail about the MBR before using some utility, and that will be very easy, of course. So let's talk about the MBR partitioning table. MBR, Master Boot Record Partitioning Table. MBR partitioning table was introduced for the personal computers back in 1983. Let us have a linear view of a hard disk. At the very beginning, we have the first sector that is known as the 0 sector. I will talk about this 0 sector after some time. Then we have a partition, let's suppose partition 1. Then we have another partition, let's suppose partition 2. Then we have another partition, let's suppose partition 3. And let us suppose that I want to have more than 4 partitions, so I keep the 4th partition as the extended partition. So this is the extended partition. And within the extended partition, I have more partitions. Let's suppose something like this. And remember, the first extended partition, the first logical partition within the extended partition is number 5. Irrespective how many partitions do you have, the first logical partition within the extended partition starts from 5. Over here we have P1, P2, P3, the primary partitions. P4 is the extended one, and within P4 we have many logical. Okay, so fine. Let's concentrate on the MBR. The master boot record is placed on the 0 sector with the stage 1 or the initial bootloader. Let me draw this. Let me have a bigger view of this. Okay, let me draw this. And we know that your a sector is of 512 bytes, starting from address 0 to, of course, address 511. The initial 446 bytes of the 0 sector contains a program that is initial bootloader. This is a program which is used to boot your system. We are not interested in this right now. So from address 0 to 445. For the remaining bytes, we have 4 entries: 1, 2, 3, and 4 of 16 bytes each. Let me change color. Okay. These 4 entries keep track of the 4 possible partitions, 4 possible primary partitions that the MBR can have. And in the end, over here, we have 2 bytes of the boot signature. Okay, so since we have just 4 entries in our master boot record, each entry can keep record of a partition, so we can have 4 primary partitions. Let me have detail of this as well. Let's suppose that this is one entry of the master boot record partitioning table. This is of 16 bytes, and the distribution of those 16 bytes are, let me change color so that I can make you understand properly. Status. There is 1 byte for status, which shows you the status of this partition, whether this is bootable or not. If this is bootable, it will contain 00. I'm writing in hex. And if it is not bootable, it will contain 00, and if it is bootable, it will contain 08. I think not 08, it is 80. We will check out later. Then we have a 3 byte partition which contains the address of the first CHS. Address of first CHS, and then we have a 1 byte partition of this partition, which tells you about the partition type. And there are a lot of partition types. 2 we have come across. One is 83, which is the Linux data partition, and if I'm not wrong, A2 is the swap partition. So over here, if it is a Linux data partition, you will find A3. Then we have another 3 byte portion which contains address of the last CHS for this partition. So we have got the address of the we have got this address as well, and we have got this address as well. Then we have the LBA of first sector. Now, of course, the LBA of the first sector of this partition may be 1, but the LBA of first sector of this partition will of course not be 1. It will be something else. So that is kept over here. Then we have the count of sectors in a partition. That is the total number of sectors in a partition. 4 bytes for this and 4 bytes for this. And since we have 4 bytes for this, that means we can have 2 power 32 sectors in a partition. And if we have 2 power 32 sectors in a partition, and let's suppose that one sector is of 512 bytes, so 2 power 32 into 2 power 9 bytes. This is the maximum size of a partition that we can support, which is 2 power 41, and which is 2 TB. So let me repeat this. Right, gentlemen, we have this linear view of the disk, and this is the 512 bytes of the 0 sector, which is shown in front of you. In the initial 446 bytes, we have the bootloader program, initial bootloader program. Then we have 4 entries of 16 bytes each. Each entry contains information about one partition. And then we have 2 bytes for the disk boot signature. And here is the contents of the MBR partitioning table entry of 16 byte. 1 byte for status, 3 bytes for address of first CHS, 1 byte for partition type, 3 bytes again for address of last CHS, 4 bytes for LB of first sector, and 4 bytes for the count of sectors. And for the total count of sectors, we have 4 bytes. So the total max size support for a partition is 2 TB. Right, gentlemen, before I move ahead and start doing partitioning, let's run a command on our terminal which makes us understand this part a bit better. Let me say dd. dd is a command, let me do man. dd is a command that is used to copy a file, converting and formatting it according to the operands. So you can read it at your own time. So I'm saying dd, please read a file which is div sda, and I'm saying it, please read just 512 bytes. Just read 512 bytes of this, and just read once and show me that. So it has shown me 512 bytes of the disk, and these are the contents of the 0 sector. Okay, can I make it readable? If I want to make it readable, I pipe it to a program hex dump. Okay, so it is readable now. You can see this is the command which I give, if you can read it out for me. And these are the first 16 bytes in hex and next 16 bytes and so on. But I just want to read the last portion. I'm not interested in the initial portion of 446 bytes. I'm not interested in these 446 bytes. I am just interested in this portion, and which is 16 plus 16 plus 16 plus 16, which makes 64 plus 2, 66. So what should I do? Let me repeat this command, and let me say I am just interested in the tail part, and in the tail part I'm just interested in 66 bytes and hex dump. Okay, to the tail I need to give that I'm interested in characters, 66 characters, last 66 bytes. Okay, let me shrink it a little bit. Okay, now you can understand it properly. So this is the command which I give, which says that read 512 bytes at a time, once only, put it in a pipe, then the tail program is just reading 66 bytes, the last 66 bytes, 4 plus 4 plus 3 plus 1 plus 3 plus 1, this makes this 16, and then 16, and then 16, and then 16, and then 2, last 66 bytes. And these are the last 66 bytes. 16 bytes, then 16 bytes, then 16 bytes, then 16 bytes, and this is the last 2 bytes, 55AA. So the boot signature is 55AA over here. Let me write it down. So the boot signature that we have read is, let me change color, yellow, 55AA. Hope you are understanding. This 55AA is this part. So let me read this part as well. The first 16 bytes. The first 16 bytes are these, and it says 0020. We have, of course, 00 over here. Then we have 3 bytes, 20, 2100. Then we have 83. We have 83. So remember, this is the address of the first CHS. This is the type of the partition type. Then we have 3 bytes for the last address, FEFFFF. We have FEFFFF. So these 3 bytes are the address of the last CHS. Then we have 0008, 0008, and 0000, 0000. This is the LBA of the first absolute sector in the partition. And finally the count. The count is 00002A01, 00002A01. So gentlemen, we have been able to read a boot sector, and don't ask me that we can change that as well. Of course we can change that as well using the dd command and giving it the OF option. Anyway, so before we jump onto the Fdisk and start manipulating this master boot record table, let me show you some pitfalls of MBR partitioning. Let me move on to the next. The pitfalls, PITFAL, drawbacks of MBR partitioning. The first drawback is you can have only 4 primary partitions. And gentlemen, now I know that you exactly know why we can have only 4 primary partitions, because the MBR has only 4 entries in the 0 sector to cater for each partition. Second, we have the max partition size. We have seen that it is 2 TB, and this is because the count of sectors in a partition is kept in 4 bytes, so 2 power 32 sectors. And if a sector is of 512 bytes, of course we can keep track of just 2 TB. And the third limitation is that the 0 sector is the only place that holds the partition. So if it is corrupted, the entire block or entire disk is unreadable. So MBR is located only at 0 sector. Let me take this opportunity to tell you about something about the GPT. GPT is replacing MBR very quickly these days. The first advantage in GPT is that you can have 128 partitions instead of 4. There is no concept of secondary, extended or logical partition in GPT. So you have 128 primary partitions. Similarly, as far as maximum partition size is concerned, instead of 2 TB, you can have 9.44 ZB, huge amount of space. And finally, of course, GPT keep its information of partitions at two places. The only requirement for GPT normally is that your BIOS should support UEFI. UEFI means Unified Extensible Firmware Interface. So today we are going to talk about Fdisk only, and some other time we will use Fdisk or part D utility to carry out partitioning for the GPT. So let's start playing now. So we are going to use Fdisk. Before you use Fdisk, gentlemen, you should know that what is the version of the Fdisk you are running right now. I hope it is visible. So I'm running 2.27.1. Okay, it's okay. Right. So the first command that you should make it your habit that you should read the man page. So it is a dialog-driven program for creation and manipulation of partition tables. It understands GPT, MBR, SUN, SCA, and BST partition tables. Block devices can be divided into one or more logical drives car partition. Please read it out. It is very informative. The options are also given. So if you give a -L option to Fdisk, it shows you information about all the block devices and their partitions. A lot of information. So give it the device name, like our device is SDA. So it shows you information in two portions. The upper portion is basically the disk size and geometry. So disk size is 25 GB in bytes and in sectors, and in units of sectors of 512 bytes. Logical and physical size of the sector is same over here, 512 bytes. Latest, this may extend this to 4 KB for better performance. Disk label is DOS, and this is the disk identifier. This disk identifier is basically used by operating system to differentiate between the storage devices on your computer. Over here you can see the partitions. We have 1, 2, 3, 4, 5, 6, 7, 8 different partitions, and in front of partition 2 we have a star over here. That means this is the partition from which is used to boot. Size is about 2 GB and its ID is 83. Remember, these are the IDs which we have talked about. Excuse me. So 83 is for the data partitions, and remember 82 is for the swap partition, and 5 is for the extended partition. So right, gentlemen, let's do what we have prepared up till now to do, and that is run Fdisk on this. So you have to be root for doing this, remember. Right, gentlemen, changes will remain in memory only. To our good luck, whatever we are going to do, it will not change the partition table abruptly, and it will be done only if we decide to write the changes onto the partition table. So you need to be very careful before using the write command. M is the option to get the help, and if you press M, you find lot of options which can be used to create, to delete partitions, and to print the partition tables, and to change from one partition type to the other. So P is for displaying the partition table. Remember, Fdisk is an interactive program. It has displayed the partition table. So if I want to create a new partition, I press N, and it says all primary partitions are in use. So I don't have free space, so I cannot add more partitions. Let me delete partition. To delete partition, you press D, and let me delete a lot of partitions. I have deleted 8, deleted 7, deleted 6, deleted 5, deleted 4, and let me print the partition table. So the partition table is something like this. Let me delete another one. Let me print the partition table. Now the partition table looks something like this. Now let me create a new partition. I press N, and this time it is asking me for the type of the partition, whether I want to create a primary partition or I want to create an extended partition. So let me create a primary partition. If I create a primary partition, I press P. It tells me what should be the number of the partition. So let it be default. I can put 4, but let it be the default 3. The first sector, let it be the default. And the last sector, instead of giving the sector, it is always better to give the size by mentioning it, for example, 2G. So if you press P, you see we have a third partition, and the size of the partition is 2G. Let me create another partition. It is again asking me that you want to create a primary or an extended partition. Since we have 3 primary partitions, this is the last time it is asking me for the primary partition. Let me create an extended partition this time. Let the first sector be default, and let me say that I want to create the extended partition to the entire size. And let me print P. And it says that we have an extended partition whose size is 11.8 GB. Let me create another partition. Now this time it is not saying that I can create a primary partition. It is automatically creating the logical partition. Let the first sector be as it is, and let me give the size as 4G. Let me print P. So we have a partition of size 4GB. Let me create another partition. The first sector size as it is, and let me give a size of 1500 MB. Let me print the partition. So now I have another partition of 1.5 G. Let me create another partition, and let the first sector be the default, and let this be the last partition, and so I give the rest of the space to this partition, and now I print. So I have these many partitions. So then when you can always play with this, but remember, never press W. If you press W, it will overwrite, and maybe you have problems later on because your partition table is only on the 0 sector. It is not written elsewhere. If you are doing it, please write down your partition table on some other sectors as well, so that you can read it from that location and write it back to the 0 sector afterwards. So I strongly recommend, whenever you are handling such utilities, in the end you must press Q instead of W. So that is all, gentlemen. Hope this lecture was informative, and inshallah ta'ala next time we will talk about the file systems, and we'll talk about the mounting of the file systems, and we will talk about the other file system types that we can use in Linux. I wish you all the best. अल्लाह हाफ़िज़।
ऐ मुजाहिदो जहां का सबात है तुम ही से, ऐ मुजाहिदो जहां